Welcome to this presentation on option delta. I'm Aninda Datta making this presentation. The following areas would be broadly covered in this presentation. What is option delta? Valuation of option delta as per Black-Scholes method. Variation of option delta with changes in spot price of the underlying asset. Other features of option delta. The Black-Scholes formula for call option valuation is given below. The BSM method assumes the asset return follows a normal distribution. The various factors affecting the option value are spot price of the underlying asset, volatility of the asset, time to expiry of option, risk-free rate of return, and the dividend yield of this underlying security. The question that comes to mind is, what is option delta? Option delta is the rate of change of a call price or a put price with change in price of the underlying asset, say a security, commodity, or a exchange. It is the first order partial derivative of option price with respect to spot price of the underlying asset. Among the factors affecting option price, the underlying asset price is the most volatile. So option delta tracking is the very important for an option trader. The call option delta is a value in under bracket D1, which is normal cumulative probability density function of D1, assuming is zero dividend yield. The put option delta is a value of ND1 minus 1. The delta is given by the formula delta of partial derivative of V with respect to S, which is the spot price. The partial derivative process to calculate option delta is given in the below link. Now, how to calculate call option delta value? The first graph has spot prices on x-axis and call option values on the y-axis. The curve shows option values at various spot prices for an option having an annualized standard deviation of 40%, time to expiry of half year, and risk-free rate of 4% and a dividend yield of 0. As partial derivative of a function is given by slope of a tangent drawn to its curve, here a tangent has been drawn that intersects the curve at x equal to 100, that is the spot price equal to 100. The slope of the tangent to the C value curve gives the delta at that spot price of the underlying asset. Here the tangent interacts the call option value curve at spot price equal to 100, where C value is 12.5. The second graph shows the spot price on x-axis and delta values on y-axis. The slope of the tangent is 0.58. So the delta of the call option at spot price of 100 is equal to 0.58. As could be seen from the curve that as the spot price increases, the tangent drawn to the call option value becomes more vertical. So the slope of the tangent and the consequent delta of the C increases, gradually moving towards 1. As the spot price reduces, the tangent becomes more horizontal, the slope reduces, and the delta moves towards 0. As call option value curve is not linear, so one tangent can be used to predict delta value of a very small range of spot prices. Now, how to calculate put option delta? The first graph shows the P value plotted against various spot prices of the underlying security. As the p-value curve moves downwards with increase in spot price, so the slope of the tangent to the curve is negative and the resulting delta is also negative. Here the tangent interacts the p-value curve at a point where spot price is 100. The slope of the tangent is minus 0.39 at a spot price of 100. So delta of p at spot price of 100 is minus 0.39. As the spot price increases, the tangent becomes more horizontal. The slope and delta of p of the p value curve obviously move towards zero. As the spot price reduces, the tangent becomes more vertical, so the slope increases and the delta moves towards -1 in this case. As there is gap between the tangent line and the p-value curve, so the slope given by the tangent line can be used to predict p-value over a small range of spot prices. For predicting a put option value over a large range of spot prices, Taylor series needs to be used. And the slide contains some other general features of option delta. The delta given by this method is absolute value and not percentage. Example, a delta of 0.61 means for every $1 increase in underlying price, the call option value increases by $0.61. It could be seen from the formula of D1 that option delta increases with increase in time to expiry, volatility of the underlying asset, and the risk-free rate of return. That the delta of a put option is equal to delta of call option minus 1, provided all other features of that option are similar, like the strike price, time to expiry, and risk-free rate of return. The call option delta value is ND1 if the share does not pay any dividend. However, the delta value for a call option on a dividend paying stock is given by the formula mentioned here, ND1 into E to the power minus QT. Similarly, the delta value of a put option of a dividend paying stock is given by the following formula, minus E to the power minus Q2 into N minus D1. So these were some of the important aspects of option. Thanks for viewing the presentation. Have a good day.